I wanted to continue with my videos on essentially on a potential orthomolecular approach to autonomic dysfunction, or autonomic neuropathy as it's sometimes called. So, of course, let's talk about GABA and neuropathic pain. This has to do with phytonutrients, flavonols to be exact, in the treatment of neuropathy. So the abundant inhibitory neurotransmitter in the brain is GABA. GABA regulates diverse physiological functions such as anxiety, sleep, reward, and memory formation. GABA also regulates the excitatory action of neuronal cells of the central nervous system. GABA releasing from the presynaptic neurons acts postsynaptically with several receptors, blah, blah, blah. Physiologically, GABA-liberating interneurons impose a robust inhibitory regulation through dorsal horn neuronal cells. Besides, damage of these neurons might additionally stimulate the dominant sensitization of the models of peripheral partial nerve injury. In rodents, injury caused the reduction of GABA release from the spine, with reduced GABA-produced glutamic acid decarboxylase. However, in diseased conditions, an improved excitation state arises that is recognized as an enormous GABAergic neuronal loss or deterioration of interneurons. Therefore, an imbalance of this condition could culminate into several neurological as well as psychiatric diseases. So keep that in mind. There's a lot of overlap between neurological and psychiatric diseases. One of the problems, as I've stated again and again and again, with psychiatric or psychiatry is a lot of times there is a physical root to the behavioral issues that are described as a psychiatric condition. Now, before I continue, I want to remind people I'm not a doctor, I'm not an ND, I'm not an MD, I'm not a DO, I'm not a chiropractor, I'm not an LPN, I'm not an RN, I'm not a CNA, nothing like that. I'm not a nutritionist, not a dietitian. But what I would like to say is what a psychiatric, quote, disease is a cluster of different observable behaviors that are subjectively observed, that are then, basically checked off a checklist. It's not scientific in any way, but it's said, oh, this is a psychiatric illness. Essentially, a psychiatric illness is a cluster of symptoms. But what you need to understand is Alzheimer's disease, Parkinson's disease, schizophrenia, epilepsy, neuropathy, and the collective role of inhibitory and excitatory neurons show a dynamic role in regulating many brain activities. It has been found that peripheral and central sensations cause nerve injury in neuropathy. GABAergic interneuronal loss is considered to be the main contributor to persistent pain states in the spinal cord. Now, this is about a different kind of neuropathy, but neuropathy is neuropathy, and I'm going to get into that in a second. So flavonoids. Flavonoids are polyphenolic compounds found in fruits, flowers, barks, grains, vegetables, roots, tea, stems, and so on. Chemically, now, what I want you to understand, these flavonoids, these phytonutrients, vitamins, minerals, etc., but in particular the phytonutrients. In Dr. Atkins' book, Dr. Atkins' Age-Defying Diet, he explains that one of the reasons that vegetables are so healthy is because of these phytonutrients, okay? And this is something that's overlooked by a lot of people. It's finally being looked at now, but you have to understand that the Age-Defying Diet was written 20 years ago. But finally, there are people, such as Dr. Furman and others, that are finally explaining to the public these plant substances. This is where the healing power of these vegetables and these herbs and these things come into play. Okay, so Apart from the separation of natural flavonoids, several synthetic and semi-synthetic products have been synthesized and separate for their therapeutic potential, blah, blah, blah. Role of flavonoid, blah, blah, blah. Okay, flavonoids are widely targeted for their peripheral events through their selective affinity for GABA-A receptors, has extensively been demonstrated in studies using bovine and rat brain membrane binding analyses. It has been found that the replacement at GABA receptor is enhanced by the flux of chloride ion. Okay. Role of flavonoid in different neuropathic pain models. Effect of flavonoid on diabetic neuropathy. Neuropathy is arduous to treat properly and is related to the remarkable impairment of health conditions as well as economic problems. Diabetic neuropathy is one of the most common causes of neuropathy and affects about 382 million people in the world. Some flavonoids such as genistein, which is from soy, narogenin, which is from bergamot, luteolin, hesperidin, catechin, camphorol, fisetin, rutin, and morin have been shown to reduce radical oxygen species level. So it reduces free radicals by increasing the level of diverse antioxidant enzymes, including glutathione peroxidase, reduced glutathione peroxidase, superoxide dismutase, glutathione reductase, and catalase in various tissues such as the liver, sciatic nerve, and brain of diabetic animals. In the diabetic model, rutin, luteolin, and morin have been demonstrated to raise the expression of NRF2. And remember, this is a pathway, what Dr. Kaufman calls a pathway. NRF2 is one of the pathways. It's an anti-aging pathway. Numerous, and what you need to understand, and why you have to read Dr. Morgan Levine's book, and why you got to read Dr. Kaufman's books, you got to understand these pathways. These are aging and aging pathways that need to be they deactivate over time, and they need to be reactivated by the use of things like phytonutrients and other nutrients, okay? So diabetic neuropathy in animal models has widely been marked by evaluating behavioral signs such as chemical, mechanical, thermal, hyperalgesia, and tactile allodynia. It has also been observed that flavonoids considerably downregulated thermal, mechanical, chemical, blah, blah, tactile. A number of flavonoids, including fisetin, baicalin, narogenin, pelargonidin, narogen, hesperidin, and luteolin, reduced diabetes-mediated thermal hyperalgesia, although camphorol, EGCG, rutin, narogenin, luteolin, morin, and narogen attenuated mechanical hyperalgesia. Furthermore, fisetin. Another thing that I want people to understand, and they need to also look into Dr. Bruce Ames's theory, the triage theory of aging and disease, where especially talking about longevity vitamins. And I'm going to go into that. I am going to go into that as I move on in my next couple videos. Probably towards the end I'll start going over that. But the effect of flavonoids on chemotherapy-induced peripheral neuropathy, the use of diverse chemotherapeutic agents and other anti-cancer drugs leads to impairment of peripheral nerves. Rutin and quercetin suppressed, blah, 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 mechanical, So these are, quercetin and rutin helped with the neuropathy. Effect of flavonoids on sciatic nerve pain. Okay. So, chronic constriction injury is considered to be the most extensively studied model for chronic neuropathic pain. There are various symptoms, blah, 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 decreased both mechanical, EGCG. Okay. An elevated level of nitro-oxidative stress can cause DNA damage, which can cause the activation of poly-ADP ribose polymerase, which can further lead to PARP-induced DNA repair by transferring ADP ribose units to the nuclear proteins. Moving on. What about the effects of exercise training on the autonomic nervous system with a focus on anti-inflammatory and antioxidant effects? Okay. The autonomic nervous system acts through two main systems, the sympathetic nervous system and the parasympathetic nervous system. Stimulation of the sympathetic nervous system brings the body to a state of increased activity called the fight or flight response. Okay, gastrointestinal tract, pre-ganglionic and post-ganglionic sympathetic neurons facilitate communication between the sympathetic nervous system and the peripheral organs. The point at which the axon and pre-ganglionic neuron connects with the post-ganglionic neuron is also the place where the cell body of the pre-ganglionic neuron can be found between the segments of the first thoracic and third lumbar spinal cord. Subsequently, the postganglionic neuron axon reaches the target organ. Norepinephrine, epinephrine, and dopamine are neurotransmitters. In response to the stimulus, most sympathetic postganglionic neurons release norepinephrine, which activates the adrenergic receptors located on the target organ. The ARS family includes 3 beta, beta 1, beta 2, beta 3, 3 alpha 1, alpha 1A, alpha 1B, alpha 1D, and 3 alpha 2, alpha 2A, alpha 2B, and alpha 2C receptor subtypes. The sympathetic endings of the sweat glands and the arterioles of the somatic muscles are cholinergic. Blah, blah, blah. This is also why magnesium helps, and I'm going to get into that. Magnesium helps because it's anticholinergic. Okay, kind of like Benadryl. Okay, it kind of works like Benadryl in that respect. Norepinephrine adapts physiological processes. Not that, don't confuse that though. Don't confuse that. Magnesium is not an antihistamine, but it is cholinergic, especially for the skeletal muscles. Okay, so norepinephrine adapts physiological processes like mood, arousal, learning, and memory, blood flow, and metabolism. It plays a variety of roles in humans and is involved in movement, memory, behavior, cognition, pleasure, sleep, and personality. Monoamine deficiency influences anxiety, depression, drug addictions, bipolar disorders, and Parkinson's disease, while excess monoamine is noticed in schizophrenia. So keep that in mind. The old MAOI inhibitor, or MOIA or whatever, they may have potentially, maybe reduced schizophrenia, but they increased issues with cognition, sleep, and personality, anxiety disorders, depression, drug addictions, etc., and Parkinson's disease. So keep that in mind. That could explain somewhat the issues with things like tardive dyskinesia and Parkinsonism in people treated with psychiatric medicines. The lower brainstem level includes blah, blah, blah. Okay. A recent meta-analysis on the central processing of autonomic functions found that sympathetic regulation involved the prefrontal cortex, the anterior and mid-cingulate cortex, and the right ventral, anterior insular, and left posterior insular cortices, while parasympathetic regulation involved the posterior cingulate cortex, the blah, blah. Okay, the autonomic nervous system and hypothalamic pituitary adrenal axis. Mental processes influence autonomic responses. Stress refers to a condition that can have an impact on a person's physical or psychological well-being. Stress systems include sympathetic, adrenal, medullary axis, and hypothalamic pituitary adrenal axis. In response to biological stress, the first neuron activated are the norepinephrine neurons, blah, blah, blah. Psychological stress, also known as anticipatory stress, can be defined as a discrepancy between personal capacities and environmental requirements. In this situation, the organism only anticipates a threat to homeostasis based on prior experience. This is what is PTSD, generalized anxiety disorder, etc. It's when your body is anticipating the need to react. So it's releasing all these stress hormones and stress neurotransmitters, etc., but they're not necessary because nothing's trying to get you. Psychological stressors depend on corticolimbic structures such as the amygdala, hippocampus, and prefrontal cortex, which are responsible for discerning between threatening and non-threatening stimuli. Both acute and chronic stress may be detrimental to health. Acute stress is normal, adaptive, reactive to threat, but may trigger cardiac events or lead to sudden death. So keep that in mind. Acute stress, meaning when you're faced with an emergency state, it is normal and adaptive, though it can, if you're not in the proper shape, can lead to cardiac events like cardiac arrest or sudden death, such as sudden death through cardiac arrest, okay? So it can lead to tachycardia and things of that nature, and also sudden death, particularly if you're not in good shape. If a person is exposed to chronic stress, the stress syndrome, the stress systems are overactivated. This is why PTSD and generalized anxiety disorder and things like this happen, and CPTSD. They can eventually collapse. Prolonged stress may influence health via several different pathways: alterations in the autonomic nervous system, neuroendocrine activity, and immune, behavioral, and cognitive functions. Chronic stress can lead not only to cardiovascular complications such as hypertension, increased risk of angina, myocardial infarction, ventricular arrhythmia. Myocardial infarction is, of course, a heart attack, ventricular arrhythmia, and acute heart failure, but also to endothelial dysfunction, meaning the arteries and stuff don't work the way they're supposed to. Metabolic disorders such as ulcers, irritable bowel syndrome, high cholesterol and triglyceride levels, insulin resistance, and diabetes mellitus. Chronic stress induces atrophy in the prefrontal cortex, meaning it makes it so you can't think as clearly. Okay, which is correlated with working memory, behavioral flexibility, and reprisal impairment. It also decreases dopamine in the brain pleasure circuits, depletes norepinephrine from I missed that part, left cortex, I think that is, or no, limbic cortex maybe, but and reduces frontal lobe serotonin receptor levels. I missed what that was an abbreviation for. You got to pay attention to those things. They do that. The PNS has received less attention than the HPA axis, blah, blah, blah. Chronic stress causes hyperactivity of the sympathetic nervous system, which occurs with reduced activation of the HPA axis, blah, blah, blah. Autonomic nervous system and the immune system. Inflammation plays a key role in promoting most chronic diseases, blah, blah, blah. The immune cell expresses pattern recognition. So essentially what happens is your immune system can become chronically overactivated from chronic stress. Cytokines are important mediators of inflammation. Interferons are an important mediator of both the innate and adaptive immune responses. So what this is going over is how the immune system is affected by chronic stress. You can read this on your own, of course. autonomic nervous system and oxidative stress. Oxidative stress is defined by high production or low inactivation of reactive oxygen species. Now, I was just reading a book by Adele Davis that I've owned for quite a while, and she was talking about the use of vitamin C to help with the with adrenal fatigue. Okay, excessive amounts of radical oxygen species. Now, of course, vitamin C is our primary antioxidant. The brain is vulnerable to oxidative stress because at this level, the concentrations of polyunsaturated fatty acids are high, the catalytic activity is reduced, and the antioxidant capacity is minimal. The hippocampus, amygdala, and prefrontal cortex are the most vulnerable structures to oxidative stress, and consequently the functional decline of these structures is the most prevalent. Oxidative stress in the brain comprises biochemical integrity, compromises biochemical integrity of the hippocampus, the amygdala, and the prefrontal cortex, affecting neuroplasticity and neurogenesis, and disrupting normal synaptic neurotransmission, as well as neurogenesis factors like brain-derived neurotropic factor. Radical oxygen species, meaning free radicals, significantly affects axonal transport, meaning how your neurotransmitters work, how they talk, how your cells talk to one another, which will lead to an increase in blood-brain barrier permeability, which means stuff can go into your brain that's not supposed to be in your brain. Nitric oxide released from the endothelium inhibits central and peripheral. High amounts of radical oxygen species can be generated in the case of hyperglycemia, which means high blood sugar, because it can cause protein kinase activation, an increase in the polyol pathway flux, an increase of the hexosamine pathway flux, and an increase in advanced glycation end products. Remember, advanced glycation end products, the advanced glycation end product theory of aging, the cross-linking theory of aging, is essentially when proteins and glucose become enmeshed, and it causes wrinkles and the different fibroses of the different organs and things of that nature. High levels of radical oxygen species can damage the molecules of lipids, which become... Now remember, you have a lipid bilayer, a lipid membrane around every cell in your body that allows the good things to go in and keeps the bad things out. If the lipid bilayer is damaged through oxidative stress or oxidative damage or some other means, bad things can get into your cell. Oxidative damage to proteins produces changes in their aggregation and enzyme activity, and can also produce proteolysis. Radical oxygen species contribute to the activation of tyrosine kinase, protein kinase C, and MAP kinase cascade, which determine the impairment of cellular responses such as activation, proliferation, differentiation. Additionally, high levels of radical oxygen species can cause DNA damage, and hence higher frequencies of mutation. The damage to DNA can be countered by DNA repairing processes. And that's where things like folate and B vitamin, other B vitamins come in. Telomeres, which protect chromosomal ends from degradation, are repaired less efficiently. So remember this, your telomeres will shorten more so if you're under chronic stress. Recent studies have revealed a close connection between oxidative stress and inflammation. Physical exercise. Regular physical exercise is a key factor for the prevention of many chronic diseases. Physical exercise can be used as a primary non-pharmacological clinical tool because it can improve antioxidant capacity, reduce oxidative stress and inflammation, and increase energy efficiency depending on the volume and the intensity and the frequency of the exercise. Acute or chronic biochemical and physiological responses are induced. Physical exercise intensity is usually expressed as a percentage of the individual's maximum oxygen uptake, VO max, or VO2 max, which means, it's their oxygen uptake. Okay, so according to the type of contraction effort, blah, 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 the positive impact of physical activity is well known and has been studied by researchers, but physical activity may also have negative impacts on the body. This is from What you have to understand is physical activity is a stressor. That's why you're reacting in a positive way to it. So it can have a negative impact on the body, especially if you're chronically overexercising, which is something that I've done. These negative impacts are less well studied and seem to be linked with oxidative stress and inflammation induced by effort. Physical exercise and oxidative stress. During exercise, an increase in respiration and oxygen uptake. This is why your body makes more endogenous antioxidants when you exercise. Okay, increased oxygen consumption due to higher energy requirements results in increased levels of reactive oxygen and nitrogen species, and other free radicals produced cause oxidative stress at the level of vital organs, and this causes cells to defend themselves against antioxidants, or against using antioxidants. Antioxidants can be divided into endogenous, glutathione, vitamin C, A, and E, uric acid, and iron-binding protein, and antioxidant enzymes AOE, superoxidase dismutase, CAT, and glutathione peroxidase. Activity undergoes changes due to modifications in the consumption of oxygen in the body. The systemic levels of antioxidant during exercise depend on the type, mode, intensity, frequency, and duration of the exercise. During exercise, the blood flow is increased to the vital organs and muscles, but is lowered to the liver, and this has an impact on antioxidant levels. Moderate physical activity. Now, this is the thing. This is what I had to find out. I had to reduce my physical activity to a moderate level. But moderate physical activity has a positive impact on the body because it helps maintain the health of bones, muscles, and joints, helps maintain normal levels of cholesterol and body weight, and also decreases levels of cholesterol and overweight. During this type of effort, the level of free radicals produced is moderate, and the body can adapt. Okay? So I do recommend that people keep their exercise, especially for anti-aging purposes. Keep your exercise to a moderate level. And I'm going to move on.